Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics 2024 examination. In this video, we discuss the solution of a problem from the section Real Analysis, and it is a multiple select question for 2 marks, and it is placed at the serial number 34. This question is suitable for all these examinations. Especially, this question is suitable for CSIR, NET and GATE Mathematics examination. Right. The given problem is, let f be a continuous function from the open interval 1 to infinity into the open interval 0 to infinity, and it is defined such that for every n belongs to set of natural numbers, its image f of n is the smallest prime factor of n. F of n is the smallest prime factor of n. Then, which of the following options is or true? Then, which of the following options is or correct? We are given 4 options. Option A, limit extends to infinity of f of x exists. Option B, limit extends to infinity f of x does not exist. So between these A and B, one of them must be true. And option C, the set of solutions to the equation f of x is equal to 2024 is finite. Option D, the set of solutions to the equation f of x is equal to 2024 is infinite. So between C and D, one of them must be true. Right. Let's now discuss the solution of the problem in detail. We are given a function from the open interval 1 to infinity into the open interval 0 to infinity. It is defined as a continuous function, and for every n belongs to the set of natural numbers, it is defined as f of n is equal to the smallest prime factor of n. Right. Let's get a feel about this function. Right. F of 2 will be 2 because the smallest prime factor of 2 is 2. F of 3 is 3. F of 4 is 2 because 4 is 2 square. The smallest prime factor is 2. F of 5 is 5. F of 6 is 2. Yes. F of 7 is 7, f of 8 is 2, f of 9 is 3, f of 10 is equal to 2, f of 11 is equal to 11, etc. etc. From these, what we see is the f of an even natural number is 2 and f of a prime number p is p. Note that for even integers 2k, f of 2k is 2, and for any prime number p, f of p is p. By the definition, f of n is the smallest prime factor of n. Right. We will now discuss the validity of the options A and options B. They talk about the existence of limit extends to infinity of f of x, whether it exists or does not exist. Right. Consider the sequence xk, where xk is a power of 2, that is 2 power k. K belongs to set of natural numbers. Note that the sequence xk, yes, tends to infinity. Yes, 2 power k tends to infinity as k tends to infinity. Now f of xk is f of 2 power k, that is equal to the smallest prime factor of 2 power k, that is equal to 2 for k belongs to n. That is, the limit of f of xk, the sequence f of xk, along the sequence xk is limit k tends to infinity of f of xk is 2. Right. Right. Now consider the sequence yk, where yk is pk, where pk is the kth prime number, that is, the first prime number is 2, the second prime number is 3, the third prime number is 5, 7, 11, etc. like that. Right. As k tends to infinity, the sequence of prime numbers tends to infinity, yk tends to infinity. Now, their images f of yk is equal to f of pk. The smallest prime factor of pk is none other than pk for all k belongs to n. So, the limit of the sequence f of yk along the sequence yk is limit k tends to infinity of f of yk is equal to limit k tends to infinity of pk is infinity. So there we have infinitely many prime numbers in an increasing order. Right. So thus we have produced two sequences, both diverging to infinity, and for one of them their images, one of the images f of xk is 2 and f of yk tends to infinity. So thus we found two sequences xk and yk tending to infinity, but their corresponding functional values f of xk and f of yk approach different limits, namely 2 and infinity. So therefore the limit does not exist. Yes, if the limit exists, if f is continuous, they must approach to the same limit. Right. Therefore, limit extends to infinity of f of x does not exist. Thus, option B is true. Right. We move on to the next slide for the discussion of the remaining two options. Right. That's what we have. We consider options C and D. They talk about the number of solutions of the equation f of x is equal to 2024, whether it is finite or infinite. Right. For every prime number p greater than 2024, this is the 2024, take a prime number, any prime number greater than 2024, then we have f of p, because it is a prime number, p is a prime number, it is p, because it is the smallest prime factor of p is p itself, which is greater than 2024. And p minus, when p is a prime number, p minus 1 is even always, because f of p minus 1, because p greater than 2024. Right. The only prime number is 2, but that's not here. So any prime number bigger than 2024 is odd. Yes, because it is greater than 2024, and p minus 1 will be even. Then f of p minus 1 is 2, which is less than 2024. So what did you see? F of p minus 1 is 2, less than 2024, is less than p, that is f of p. That means 2024 lies between f of p minus 1 and f of p. Right. Now f is continuous on the interval, closed interval, p minus 1 to p, and 2024 belongs to f of p minus 1, comma f of p, that is 2 comma p. Right. 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 Now, by the intermediate value theorem, because f is continuous, there exists a c belongs to p minus 1 to p, which takes every value between f of p minus 1 and f of p. That is 2 and p. That is, in between f of p minus 1 and f of p, there is a 2024. It assumes every value between f of p minus 1 and f of p. That is precisely the intermediate value theorem says. And there exists a c belongs to the open interval p minus 1 to p such that f of c is equal to 2024. And this happens for every prime number p. For every prime number p, you can find a c. Since there are infinitely many prime numbers p greater than 2024, this happens for every prime number p greater than 2024. Yes, that's what you have to say. And there are infinitely many prime numbers which are bigger than 2024. Therefore, this produces infinitely many such c. Right. So, therefore, this shows that the set of solutions to the equation f of x is equal to 2024 is infinite. What is true? Option D is true. So thus, option C is not true and option D is true. We have already shown option B is true. Therefore, the answer to this question is options B and D. That is the detailed discussion of the solution of this problem. It is definitely an interesting problem. And this question is most suitable for the CSIR NET and GATE mathematics examination. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.